Hi, welcome to this video. In today's video, I'm going to look at a very interesting integral. As we have the sine x over x dx as x goes from 0 to plus infinity. This integral is already evaluated by Cauchy residue theorem. But today we are going to see the different method. It's called Laplace Transform. Okay? So the only problem that we have in this integral when we have x at the denominator, so we have to think how to cancel out this x from denominator. Okay, we are going to choose a new function which can help us to reduce this expression. Okay, so let's set I of a equal to this integral from 0 to plus infinity. Sine x over x is multiplied by another function which is minus e to the minus xa dx. Okay, so what I'm going to do now, I'm going to maintain this expression to make this integral work. Okay, so if you replace this integral by I of a equal to 0, okay, if you replace 0 into this expression, it's taking you back to the original integral, which is logical. Okay, the second thing we should notice here, in order to have this integral evaluated, we must have this function convergent. We have to have this condition, a must superior or equal to 0 in order to have this function convergent. Okay, because if you have this a negative, with this negative sign become positive. When you plug plus infinity into x, is taking you to infinity. So this expression, this function will be divergent, which is not gonna work here. The next step, I'm going to differentiate this one. Okay, I'm going to derivate this function and integrate it back. Okay, so I'm going to use this notation d. So I will have I prime of a equal to d over dA from 0 to plus infinity sine x over x e to the minus xa dx. Okay, as we derivate in this one, notice here we have two variable functions. We have two functions with different variables. We have x and a. Okay, so I'm going to bring this one inside by applying Leibniz rule. It becomes from 0 to plus infinity. I'm going to use the partial differentiation. So I will have this one is written on this form with respect to the a. So I will have sine x over x e to the minus xa dx. So in this case, x is a constant, a is a variable. Okay, f prime of a, I'm going to bring sine x over x outside of this one because it's considered as a constant. So we'll have this integral from 0 to plus infinity sine x over x, differentiation of this one, the partial differentiation of e to the minus xa dx equal to from 0 to plus infinity sine x over x. I'm going to derivate this one. I will have minus x, because x is a constant in this case, is multiplied by minus xa dx. Now this x will be cancelled out with this x. I will have a new integral I prime of a equal minus, and putting minus sign outside, I will have this integral from 0 to plus infinity is multiplied by this function minus xa dx. Okay, by using integral by part, let's set du equal to e to the minus xa, and v function is sine x. Okay, so let's call this one as a g integral. Okay, so this means g integral equal this one. I'm looking for a primitive of this one, which is minus 1 over a e to the minus xa is multiplied by sine x, the bound from 0 to plus infinity, minus integral 1 over a outside. With this minus sign will become plus, is multiplied by minus ax. I'm going to derivate sine x, it becomes cosine x dx, the bound from 0 to plus infinity. Since we have this a positive, as we mentioned before, when you plug plus infinity into x, since a is positive, this term equal to 0, okay? Minus 0, because when you apply 0 into sine x, is taking you 0 as well. Entire thing equal to 0, okay? So for this integral, I'm going to do the by part from 0 to plus infinity e to the minus ax cosine x dx. Okay, so let's put this one g prime integral. So g prime integral, I'm going to do the same thing by parts. So I will have this function minus 1 over a e to the minus ax cosine x, the bound from 0 to plus infinity, minus the integral minus 1 over a, because I'm minus 1 over a. I'm going to derive this cosine x, it become minus sine x. With this minus become plus sine x dx. If you take a look at here, this is the same integral that we have in the beginning. So this one. So I'm going to evaluate this term. If you plug plus infinity into x here, is giving you 0 because a is positive. If you plug 0 into x, is giving you 1. If you plug 0 into cosine, is giving you 1. 1 is multiplied by 1 is equal to 1. With minus 1 over a, which is minus 1 over a. This term equal to minus 1 over a. Okay. So I'm going to write this one as a new integral. Put the whole thing into expression. So I have g integral, which is this one. This term here, which is g integral, equal to this one, which is minus 1 over a, 1 over a, g integral, because this is g. This one is given as minus 1 over a square, minus 1 over a square g. And bringing g term to the other side, I will have g is multiplied by 1 plus 1 over a square, equal to minus 1 over a square. Okay, I'm cancelling out a square from both sides, so I will have a square here plus 1. I put the denominator is a square, it will be cancelled out, so I will have g equal to minus 1 over 1 plus a square. Okay, I'm bringing this one at the top and continue with our problem. So in the last board we were working on this derivative function. We found I prime of a equal to minus 1 over 1 plus a square in terms of a. Okay, I'm going to integrate this one back in order to go back to the original integral. Okay, I will have a of a called the integral of minus d over a 1 plus a square. Okay, this one, as you see here, of a equal to, I'm putting minus sign outside of this integral, so we'll have equal to minus arctangent of a plus constant, because we don't have the bound. We must put the constant and find out the constant. So I'm going to, now what I'm going to do now, I'm going to find out the constancy. So this one is equal to this expression from 0 to plus infinity, sine x over x is multiplied by minus xa dx. Okay, if you plug 0 into a, is taking you back to the original integral, then arctangent 0 plus c, that means c equal to this integral, which doesn't make any sense. We have to find the constant c as a number, not as a function. Okay, if you plug plus infinity into a, the whole thing equal to 0, because if you plug plus infinity into a, so this one it will be 0, so that means the whole thing will be equal to 0. So as a is going to plus infinity. So on the other word, so if you plug plus infinity into this one here, is given as minus arctangent plus infinity plus c equal to 0, because this one equal to 0, right? So arctangent of plus infinity equal to minus pi over 2 plus c equal to 0. That's mean this equivalent c equal to pi over 2. So my integral now as I of a equal to minus arctangent a, not x, a, because we have different variable, plus pi over 2. Okay? But I need the original integral, which is 1. By plugging, in order to find the original integral, which is sine x over x, we must replace a with 0. Okay? So now I have a of 0 equal to this integral from 0 to plus infinity sine x over x e to the minus 0, okay, dx equal to minus arctangent of 0, because we are plugging a with 0, plus pi over 2. So that's mean a equal to 0, which this integral, that's what I'm looking for. This integral which is required to be calculated from 0 to plus infinity sine x over x dx. Arctangent 0 is 0, so plus pi over 2 equal to pi over 2. Okay, my integral equal to pi over 2. So now I have done with this problem. We will see more examples in next coming videos. Okay, just consider subscribe. Thank you for watching. I will see you in next video. Bye.